Here today for another edition of Community Conversations for Tecnomatix Plant Simulation, our virtual user group. Today's topic is on how to create a Kanban system using the supermarket function. And as many of you already know, our speaker is Stefan Bongsau. He is a freelance simulation expert who has been in this space for quite some time, doing hundreds of projects and training sessions. He has published already 5 books on plant simulation and is working on one presently. And he is definitely one of our biggest contributors to the Siemens PLM community. And he was also just awarded a Techcellence Award at Realize Live Americas just a few, was that now 2 weeks ago. So we're definitely glad to have him here and appreciate his expertise. For our topic today, these are the steps. As a reminder, as always, we are live. Stefan will be presenting to you live. He will start by showing how to configure the supermarket setup, to set up order-based sources, and then to create a basic scenario for those. Again, the presentation is live, and we will have a live Q&A at the end. So definitely feel free to jot your questions in the chat. And then definitely, because we are live, you can also raise your hand using the button at the top of your screen during that time, and we will take you off mute so that you can ask a question verbally as well. But with no further delay, Stefan, feel free to take the screen.
Hello again for our next webinar. Today, we want to create one very basic Kanban production system using the supermarket functions of the store. If we want to create a Kanban production system, we need to start at the end. At the end of the complete production line, we need to start with the customer orders. And so we start with a train. And one way to create customer orders, I showed already in one of our webinars. We had one webinar for create order data for customer calls, for instance. And you can use one assembly station to create orders and pull all the parts that you need for the orders from one store. And so we start at the end here with our model. We need one assembly station. And we need a source. And we need one table for the customer orders. I want to have here a random behavior with this table as data source. Press apply, and then Plant Simulation will format this table here. I want to use the container for 3 different order types. Frequency first is 50%, 30%, and 20. Each one. One is AC, one is AB, and one is CC. One order is 1E and 1C, and one is 1E and 1B, and one is the third one is 1C, 2C parts. To make it more visible here for us, we create 3 parts, duplicate the part here. First is A. I duplicate this here. Next is B. And one additional one is C. And we change the color of these parts here. The first we can let the light gray, what is default here in Plant Simulation. B should be red. And so edit 3D properties, appearance, activate the material, and select the color red here. And C, maybe it's blue. So edit 3D properties, appearance, activate the material, and select as diffuse color a blue color. Okay. I make the first connections. Assembly goes to train, and this is my main part. My containers where I collect all the customer orders, and I need one store. I rename it as assembly. Store. And this is the source for all the parts I need for my customer orders. Okay, the next step, I need to configure my assembly station. My assembly station should attach the MUs, and assembly table should be depends on main MU. We also had already one webinar to create dynamical here bill of materials and change this assembly list in the entrance control. If you have a lot of different customer orders, then maybe it's easier to change the assembly list based on the packing list, for instance, for the customer orders, instead of making all custom orders here fixed in one list. And also you need to make it more dynamically if you have random created customer orders. Okay, we make it here static. Main MU name is AC, our first one, and MU name is 1A and 1C. The next main part is AB, and we collect 1E and 1B. And CC should be to part C. Okay. Then we set a time. The time should be 3 hours. I want to create a Kanban system with two control loops, a two-stage Kanban system. In a two-stage Kanban system, we have at least we have two different control loops. We have one control loop for control the production, for trigger the production of parts. And we have a second control loop for green parts from suppliers, for instance. If we need some parts, for instance, here in the first control loop for production, when if here this store needs, for instance, part E, we need a place where we order this part E, and this should be, in our case, another store, and so we need a second store. And between this store green part and this assembly store, normally you have your complete production. And I start here with a buffer. Change the capacity of the buffer to -1. And then maybe I have 1 or 2 stations. In this case, it's not really interesting. It's in reality, it's this production. And here I connect these stations with connectors in this way. Change the proc time to 1 hour. If you have sub-assemblies, there you could be also more control loops in the production itself. If you have to assembly sub-assemblies and deliver sub-assemblies and parts from the assembly store, then maybe you have one step more here and one store more. And we connect the store green parts with this buffer. And then we have a second control loop to get all the green parts from our suppliers. And this I don't want to model in detail. I want to have here a source. For all the green parts. And I place here one additional buffer with capacity of -1, just to model the delivery time. And so I renamed this in transport green parts, and you can set a dwell time in the buffer. For instance, 1 day. To model the transport time from your supplier into a company. And we connect this with connectors. Okay. So 2 stages, 1 control loop. Normally you have also different kind of Kanban cards. One type of Kanban card are production Kanban. A production Kanban is yes, the trigger for producing something, and transport Kanban is a trigger to transport something. And you can have both in the first loop already. If you have here in the store green parts already, parts that you directly transport to the assembly store. So now we need to create these control loops, and this we do in 2 steps. First step is we need to configure our assembly store, and I don't know, until I guess 14 or 15 there was a Kanban library in Plant Simulation. And now since 16, I guess, or 15, all the functions from the Kanban library is integrated here into the assembly store and into the source. So we need to activate the supermarket. Or stop, we need first, oh no, and click on configuration. This is quite the same like in the Kanban library. In the form we need to set the part type, so the store can create, for instance, one initial stock. Name is A. Maybe minimum is 10, maximum is 50, and we start with 35. And we need to specify a supplier, and the supplier should be the store green parts. Press enter and you get a new line. The next is our part B. The name is B. Start with 10, minimum 10, 50, and initial stock should be 15. And same deliverer, supplier store green parts. And our third line is use objects C, also 10 to 50. And we start with 50, the complete stock. and the supplier again is store green parts. So you can have a lot of different suppliers. Okay, if you press apply, Plant Simulation will change your store icon here. Each part type is now in one cell, and it will get a stable here, a stack. And so we can observe all the changes. And you can see you cannot change the dimension of the store anymore. Okay, this is the first step. Plant Simulation, if you pull parts from the store, and you will reach the minimum stock, then this assembly store will order all the parts up to the maximum stock from your supplier. And the supplier will deliver these parts in direction of the connector. And so you can have, after this supplier here, for instance, one place where you pick up the parts with a HEV, for instance, or you pick up the part with a worker, or just beam the parts somewhere. And here you don't need a buffer. Plant Simulation will remember all the parts that are requested, and also if there are no stock here in the store of the supplier, then Plant Simulation will remember all the missing stock and will move these parts if they are available. Okay. This is our first control loop. And the second one is from here, from the green parts to the source green parts. We need to configure this store in the same way. Activate supermarket. We need our 3 parts. MSE, B, C. Oh. Oh. Okay, and the supplier is source green parts. And this control loop works in the same way. If we pull parts, for instance, here by the assembly store from this store and reach the minimum stock, then Plant Simulation will order all the parts up to the maximum stock from the supplier. And so we need to configure also the source, but it's only one click. Change MU selection here for the source and make order controlled. And then this source will create part at a time when we need them, and also it will create the part we need. And you have here also one method in SimTorque. The method is order parts that you can use for the source and the stores to order parts with SimTorque. But not today. So today we make it completely in the automatic way. That's it. Now we can test this. Yeah, I make some change here. And then I make it faster. Okay. You can see the consumption. I guess 10,000 is better. The consumption of the parts. And if we reach a certain, our minimum stock, then this store will order the parts from the green part store and move them here to this buffer. And after production, it reaches here our store. And this store green parts will order all the green parts from this stores, and it takes a while until the transport is it's reaching here our store, and then we fill up our stock. And so we have now a very basic Kanban production system. Okay, this is a very basic approach. It's the same approach like in the Kanban library of Plant Simulation in former versions, but there are some missing points here, and you need to be carefully if you need to model a Kanban system. And for instance, especially if your customer is a Japanese company and they use Kanban system in a much more restrictive way. And so there are some points missing here. Okay. The first thing that's missing here are Kanban cards. If you make optimizations in Kanban systems, then you need to reduce the number of Kanban cards for some group of parts, for all parts, for production Kanbans, for transport Kanbans. And the key figure is the number of Kanban cards. And if you don't model Kanban cards, then it will be hard to reduce them. Another problem is Kanban cards are connected with boxes in many cases. And here we are modeling MUs. And this may be different from the practice in the companies. Maybe they move one part out of the box keeps in the store, and then they already separate the Kanban card from the box, and the Kanban card will be sent to the production. And so we have a time gap here. Maybe there is some kind of Kanban post which takes also time and needs to be considered in your model. And all the box handling, you cannot do this in this way here. We can say, okay, this is one box, but normally this box has a capacity, and the box capacity can be also one topic for optimization. What's the optimum box size here for which kind of parts? And so this may be not fitting in our approach with the MUs here in the supermarket. We can make this as a box, okay, but we cannot remove parts out of the box with the assembly station automatically. If we connect this in this way with the connectors, then it consumes one MU with one depend on the assembly list. And so one big problem in reality are stores with parts in different states. Problem, yeah. If you have here one store and you have several types of part E with different states of production, then you have a problem with this assembly with the supermarket, because the supermarket, also the function order parts, doesn't consider some state of production. If you have to store and remove the parts several times from the same store, then you cannot use this supermarket for this. There you need to implement your own warehouse management system. But for basic Kanban systems, this is quite a really fast way to model this. Okay. Any questions?
Okay, hi. Thank you for the webinar, by the way. It was very helpful. My question is, can we also count the number of orders sent to the sources or the assembly store?
We need to pull. We need one mechanism to pull something, and the source connected with the assembly station is really an easy way to use all the function of the source for this. For instance, you can use a delivery table here in the source, and so you can import your delivery lists that you have from your MES system, for instance, and can use the times, for instance, to pull the parts out of the source, out of the store, like in reality. But you can also make this with with SimTalk. But it's you need data for this, yes. again your question, please?
I mean the first source, the supplier source. In the green part store, we are sending orders in the Kanban system to this source, and can we count those orders?
Oh,
how many
no,
orders?
no. If in a Kanban system, you only order the parts you consume. You don't put. There are two ways. If there are push systems where you have a plan, for instance, for source green parts here, and deliver the parts, independent. You need them or you don't need them, but this is not a Kanban system. A Kanban system only pulls the parts you need. But you can, there are mixed system, pull-push systems, where you push until a certain point. For instance, here with a source and a normal delivery table or a plan, and then you push all the parts into a source, into a store, for instance, store green parts, and then there you start your Kanban system. You can mix them, these two approaches.
Okay.
So you can have here, yeah. The source for the supermarket table can be only store and source or any other object. You need something to pull here. You need to consume parts here. You can do this with a generator and a method and delayed parts here or order parts. You have order parts, the method in SimTalk, and so you can use, for instance, also a method and a generator to remove parts from the store. But you need to remove parts from the store to start this this control loop. Automatically, it's only works with the assembly station. The assembly station is the only station that it's able to pull several types of parts out of the store.
It looks like there's another question in the chat.
Yeah.
What changes would I need to do in the assembly station if I have customized orders?
Yes, it depends where you have the orders. If you have, I would make here the changes in the entrance control before actions in the assembly station. If you want to pack, for instance, all parts together in one box to have one customer order ready, then you need to change the assembly list of the assembly station. And this is the latest point where you can do this in the entrance control before actions in the assembly station. And there you can read your order, all the parts and the quantity you have, and write it into the assembly list of the assembly station. Okay, there's one more hand.
Thank you so much. So thank you for the content, is very interesting. And my question is about the stores and the Kanban itself. So can we see like in a chart the leveling of the buffers, like the Kanban that you created? So if we are like between the minimum and the maximum that you defined. And my second question is, if we will be below the minimum that you set, does it stop, or it can like have like it can consume from the minimum until it reaches zero in this model?
Of course. This the minimum stock is for security. If you have a delay in the supply, then you can use the parts from the minimum stock until you don't have any more. And one of the optimization in such models is to find the right numbers for the minimum stocks for the several types of parts. How many minimum stock you need to level all your delays you have inside your production. but it will deliver until it comes to the end. And then if you have more requests, then you find it here in this awaiting column in this kit. And for statistics, you can every time make one try here, take one chart, and then just move the store on the chart. So, and okay, then should already have all the occupation here. But this is not a histogram. Not a, okay. Okay, and so we need also only to change here the axis to have 1 day, for instance, or 10 days, and more values apply. And then we have the development of the stock here during the time. So just track the store onto a chart, and then you have already your charts, and you have access on the table behind, and you can read all the data. For instance, how many parts are waiting for delivery.
It's getting pretty interesting in the chat. There was a clarification on an earlier question around the table that you were filling in the store, and a question about the source there. That if whether or not only one source could be selected. I think this is Sanya.
You can. You need some. There are only 2 elements now that are that support order parts. The method. It's only the source and the store. So you can only use a source or store. I don't know what happens if we try to select another one. I can just try it. So transport green parts. Okay, that's wrong. So you have the supplier has to be of type source, store, or method. Okay, method we can also use. Okay.
So I think the next question was in the chat. Ravi is asking about, or Danesh Ravi is asking about, I need to model in such a way that whenever my buffer is having I'm assuming minimum stock, right? AGV has to pick the part from the source, then deliver to the destination buffer. So is that possible?
Not from a buffer. This supermarket function you have only for the store. But yes, you can have a store with only one line, and then set up your minimum maximum, and then you need to connect it with another store and place just a buffer in front of the store and then you can react on the buffer occupation. If there's a part, then you can pick it up and or yes, you can also use source green parts for this, but it's limited only to source and store and method.
Looks like that was a satisfactory answer, so that's good. We still have time for more questions. Definitely don't be shy. Raise a hand or get them in the chat. If we have empty time, it seems like everyone's thinking. I do always like to share where these recordings end up in our customer community. Let me show that slide really quickly while you all think about your next question. This slide that should be showing is this one. So what you see on your screen right now, there's a little animation going of our page for the Plant Simulation Virtual User Group, where these recordings are posted. You can click the link on your screen. You can actually click it and go there right now. And the registration. So you can see the dates for the next one. We'll have a session on June 26th, and then we'll take a break in July for just vacation for Stefan and some of us on the team. And we'll come back in August and do these sessions again, usually 2 a month. So the best way to keep in touch with what we're doing is to go to the link on your screen and then to click the button that you see in the animation that says follow. And so when you click that, there are 2 options. You want to choose every post, meaning that you'll actually receive emails. Every post might sound like a lot, but the only thing that is posted in that area of the community is when we have, again, the on-demand recordings are available. We are releasing dates and registration for a new session, and then questions specific to these topics. So if you watch this video or you send it to a colleague and then they have a question, you can always post in this area in the community. You can mention Stefan and he'll make sure that your questions get answered. So that's the only thing this part of the community is for. That's the only thing that URL is for, just for plant simulation and around these tutorials.
Yes, I have one more question. For this, when we select the supermarket option for the warehouse, then can we also use these minimum maximum values that we defined as a metric in experiment manager or in, I don't know, genetic algorithms tools, if we want to optimize also these values, or should we do them separately?
Okay, look here, the direct help, click on configuration, and here you get configuration, and you have 2 methods, get supermarket configuration and set supermarket configuration. And so you can define a global variable, for instance, and write with set supermarket configuration this into your supermarket. It's similar like the assembly list and other configuration tables. You don't have direct access, but you can set a value, for instance, in a global variable, and then change the global variable with the experiment manager or with the genetic algorithm, and then you can set this value, for instance, in an init method into the store. Yes, it's one of the basic experiments you have to do here to find out what minimum value, minimum stock I need, how many players I need for this Kanban storages.
There was a quick question also about suggesting topics, which I mentioned. Yes. You can also do that in the forums in the same link, which is now in the chat. So definitely go there if you want to suggest topics.
Or mail me, or you can also send me a message in the forum directly. But we have already a topic there with all the success or the topics.
Stefan's profile in the community is now on the screen where it says the @ sign and then Stefan. So if you click through there, that will take you directly to his profile in the community. You can always mention him in that way, or there's a way to message directly from someone's profile. Well, that's great. Thank you everyone for coming. Thank you, Stefan, for another really excellent presentation.
Thank you.
And we'll see everyone in the community.
Goodbye.
Bye.